Hello, Algebra 1 students, and welcome back to your Semester 2 final review. We're looking at problem 40, which comes from lesson 10.6. We did a lot of word problems in that lesson. A model rocket is launched from the top of a platform 6 feet above the ground with an initial velocity of 125 feet per second. The function h of t represents the height h of the rocket t seconds after it is launched. What is the maximum height of the rocket to the nearest foot? Alright, so we discussed in lesson 10.6 how these equations are built, where there's an initial height, there's an initial velocity, and then this is our gravity constant. And that gravity constant is always negative because we want our rocket or our particle or our ball or whatever to eventually come back down to the ground. And so that negative is really important because it tells us with this negative squared that my graph looks something like this. And now that we know the graph looks like this, we can at least visually see where the maximum height is going to be. It's going to be right here. That's the top of our parabola, which we call the vertex. So when they ask for the maximum height, what they really want is what is the vertex of our parabola. So we've done this vertex trick several times, and I'll just remind you without going through the whole spiel. Our vertex has the form h comma k. The h value, if we are in standard form, is found by doing that part of the quadratic formula, negative b over 2 times a. So let's identify a and b really quickly. We know that a is, of course, this guy right here, and b is the next one in line, which is 125. This gives us negative b over 2 times a, where b is 125 and a is negative 16. These numbers are starting to look a little gross, so you might want to use your calculator to try and reduce them. This gives me negative 125 over negative 32. And then to reduce, and you can keep it like that, to reduce you can type this into your calculator and either it will reduce it for you depending on your calculator, or it will give you the decimal equivalent, which is fine as well. So I'm going to go ahead and open up my calculator at the same time once my screen loads here. And where'd you go? There it is. We're going to type in negative 125 divided by negative 32. So negative 125 divided by negative 32. Excellent. And this gives me 3.90625. Oof, that is a rough one, isn't it? So 3.90625, I'm going to write that down. 3.90625. Okay, so we found the first part of our vertex, the h. Well, let's go ahead and find the k value. The k value involves taking this and substituting it in for x, or in this case in for t. So we're going to have negative 16, 3.90625 squared, plus 125 times 3.90625 plus 6. And boy, am I happy that I have a calculator here. So we have negative 16, and you guys should try this too and make sure you get the same thing that I do. And then most calculators can substitute an answer in, so you could type 3.9 whatever. I'm going to go ahead and just do second answer so I don't have to retype it. That takes the previous answer. I'm going to square it plus 125 parentheses previous answer, so second answer, and then plus 6. And when we do all that, we get 250.140. So let's see here, 250.140. All right, so let's try and understand which one of these values is our right answer. Now, I mean, clearly from the multiple choice, we know it's going to be the 250. But do we understand what both of these mean? 3.9 was substituted in for what letter in the equation? Well, I think 3.9 took the spot for t. So 3.9 here is going to represent the time. And the time with what? Well, they told us the velocity is feet per second. So our time, I think, is in seconds. So at 3.9 seconds, the rocket is at its maximum height. What is the maximum height? Well, we know it's going to be in feet. It's the output when you input a time, and it's approximately 250 feet. So when they're looking for the maximum height, just like when we did the maximum value a couple problems ago, they want the y value, 250. And that is all there is to it. They asked for the max height, find the vertex, find the y value, and you are done.